Welcome back, guys, this is AESIR speaking, and today we are going to talk about our flight computer Morfeo and all of the 3 generations. I would also like to thank all the new followers on Instagram and subscribers on YouTube. So let's get started, I guess. How does a flight computer work? So when you have to make a project, especially about electronics, keep in mind that you have to know exactly what you want from your creation. Here's our steps to successfully make an electronic project. And also they'll help us explain to you guys how to understand the process of making Morfeo quite a real thing right now. Step 1. Just grab a piece of paper and write down what you want from your project. In our case, we want a model rocket flight computer powered by a LiPo battery capable to record flight data and pop a parachute out like a recovery system. Step 2. Begin to write down all the data that the microcontroller is going to need to provide as an output what you want. In this case, in order to know when Morfeo has to pop the parachute of the rocket, we need what is called an IMU, Inertial Measurement Unit, that can give us data about acceleration, position, and a bunch of stuff, and in combination with a barometric pressure sensor, or BPS for short. You have to know that one of the factors that can influence the atmospheric pressure is the altitude on where we are measuring. And there is a specific formula that can give us the altitude at where we are at given the ambient temperature and pressure, so we can easily calculate the variation of altitude. Talking about data recovering, we just opted to record all the flight data to a flash chip during flight, and once we had touched the ground, the microcontroller can just copy the data to a micro SD card, easily pluggable on any device quickly. Step 3. In this step, just start picking up all the components needed to gather all the information that you need and effectors, if you need any. An effector is a sort of device that can do something if there are the right conditions to influence the environment or not. In general, something that can cause an event. In this case, the effector is a P-channel MOSFET, a sort of electrical switch that can fire a charge inside the nose cone of the rocket in order to make the parachute pop. Again, this is not a detailed video. We are going to make more specific videos about each and every topic of this computer. But also there are still concepts that you already need to know in order to follow this video along that we won't going to explain completely. I'm going to leave in the description down below some links to videos that can explain easily more about different topics. Morfeo Generation 1. Morfeo Generation 1 was the first generation of flight computers that we've had. At that time, almost 1 year ago, we knew almost nothing about PCB design. So looking back at this generation, we can say that despite all the difficulties, we've done a pretty good job so far. Here's the specs. So like a microcontroller unit, we are using an Atmel Mega 328P, so an Arduino Nano. Like an IMU, we are using an MPU 6050, and like a BPS, we are using a BMP 180. This flight computer cannot communicate to a ground station via radio frequencies, and its nominal current draw is about 51 milliamps. So with this flight computer we have found some problems. For example, a non-working flash chip was the biggest error from our part. Ignoring that, the Arduino Nano works at 5-volt logic, but the flash chip that we have been using was working at 3.3-volt logic. So it doesn't make any sense, they cannot communicate properly. pretty much a test bench to see if we could handle this problem in the most simple way. And we did! From development to the final product, passed at least 1 month, so we moved forward to the next generation. Morfeo Generation 2. Morfeo Generation 2 was really when things started to get better in terms of performance, but also way more complicated in terms of code. Like a microcontroller unit, in this case we have used an Atmel Adsum D51 based on the ARM Cortex M4 architecture running at 120 MHz and with 192 KB of RAM, all included in the itsy bitsy M4 development board from Adafruit. And what's great is that in the same development board, a 512 KB of flash is integrated, communicated via quad SPI with the microcontroller, so great read-write performance. Like an IMU, we have been still working with an MPU 6050, like a barometric pressure sensor. We have still been using the BMP 180, and in this case we have added some new features like radio communication using the NRF24L01+. The nominal current draw is about 111 milliamps. The problems with this PCB was a damaged radio module, and the top left mounting hole is too close to the battery plug. As I told you, we've added some new features to this flight computer. For example, an external I2C port for a GPS module that unfortunately we have never used. This board, if we have to be completely honest, was pretty much a playground that worked magnificently in terms of performance and features. What a pity for the damaged radio module, but at least for the first days I can guarantee that it worked as a charm, communicating data to a ground station. Upcoming Morfeo Generation 3. So this is a complicated topic. The goal of Morfeo Generation 3 is to not use any breakout board, but only ICs in a PCB. We've got to be honest, we have already tried this several times and we have learned a lot. And this is way more complicated of what we have done in the past. The only modules that we are going to use externally via cables pluggable to the main PCB are the radio module and the GPS module. We don't want to mess up with any radio type PCB. The only thing that we can spoil to you is that we are considering to use the ESP32 like a microcontroller. The Adsum D51 is great, but we don't really want to get involved with bootloaders, and so everything still needs to be decided. So if you can help us understanding more about the process of uploading the bootloader to the Adsum D51, the same bootloader used in the itsy bitsy M4 from Adafruit. Another news is that we are going to share with you the process of making Morfeo Generation 3 with videos on YouTube, live streams on Twitch, with the help of you guys. This video is over, so make sure to follow us on Instagram for any update. Obviously, go check out our Twitch channel and Telegram channel. As always, the links are down below the description. We will see in the next video. Persevere, always.